Welcome to all in Examrace. We will see the important questions, some tricky questions related to the CSIR Physical Science. In this question, two distinguishable non-interacting particle and each of mass m is there in a infinite square well. Just look at this important thing. And it has interval of 0 to 4. The positions are there and x1, x2 are the certain positions operator of two particles. Now what we have to do, we have to find the expectation value in the state in which one particle is in ground state, other particle is in first excited state. Okay, so we have to do this. Now first is to find the net function. So net function is not going to be your psi1 plus psi2. If psi1 is a function for first particle, psi2 is a function for second particle, then your net function is going to be psi1 into psi2. Just remember this first thing. Now what is the function for infinite square? Well, it's going to be the root 2 by a sine n1 pi x1 over a, because the two particles have same infinite square well is of limit 0 to a. That's why a is same. So here also it's 2 by a sine n2 pi x2 by a. Now remember one thing, here n1 and n2, n1 is equals to 1, okay, and n2 is equals to 2. Why? Because n1 is regarding the ground state and n2 is regarding the first excited state. Clear? So this is your function, we can say. Clear? This is your net function we have. But we have to find something else. What we have to find? We have to find the expectation value of x1 and x2. Okay, so it's going to be the integral of psi, is going to be double integral actually, psi asterisk. Okay, this is net into x1 x2 psi net dx1 dx2. Clear? So I'm going to break this, just look at this. It's going to be the integral is from 0 to a. This is given that the potential valve has the limit from 0 to a. So it's psi1 x1 psi2. Clear? Then 0 to a psi2 x2 psi2 dx2, and this is dx1. Clear? Now what we will do now, we have psi1 psi2 as we already seen. What is psi1? Psi1 is root 2 by a sine n pi x1 over a, and similarly you have psi2 also 2 by a sine n2 pi x2 by a. So one thing you will do, you just put the values and you just integrate, and this is going to be a long process. But what we have to do, we have to integrate this. But remember one thing, whether it's a ground state, first excited state, second, third, fourth, nth excited state, when we talk about the infinite square well, the average of that is going to be a by 2, or whatever the width of the square well is going to, half of that is going to be the average. So here width is a, so it's a by 2 here for this one. This is simple, and also this one a by 2. So this is what we can apply to save the time and get the exact answer. Clear? So no need to integrate, and it's just time consuming. So a by 2 is going to be the a by 4. So this is your expectation value of x1 and x2. Clear? Now in this is a problem regarding the Dirac delta function, which shows that Dirac delta function is very important for the exam. Now you can see the two functions are here. One is inside the Dirac delta and another is outside. So we consider this as a g of x and another function is f of x. Now how to deal with this type of problem? First we have to find the roots, whatever the function inside the Dirac delta. So it is 0. To find the roots we have to put gx is 0, so its sine of x is going to be 0. Clear? Now, if sin of x is going to be 0, then what we will do? We got the x as 0 plus minus pi plus minus 2 pi and goes on. Clear? Because x is equals to n pi, that's why. Now the problem arises how to find the integral. So for this is a simple trick that what we will do to find such type of solution for such type of integral is going to be the f of x over g dash of x. Okay, now you see this, the roots are 0 plus minus pi plus minus 2 pi. If you see the value of x, is these values of x are all values are lying inside the given limit of integral? Yes, it's from minus infinity to infinity, so it includes all the number, whether it's positive negative doesn't matter. So all the values of x, all the roots of x is going to be inside, means is in the limit of the given integral. Now if it is in the given limit, then what does it mean? It means that the value is not going to be 0, it has some finite value for each and every value of x. So we will consider summation of x equals to 0 plus minus pi, and this goes on up to infinity. Now just put the value of f of x. F of x is your 2 minus x by pi. And what is g dash? G dash is differentiation of gx, and that is sin x differentiation cos x and more. But summation is there, is from x equals to 0 plus minus pi to infinity. Okay, this goes on. So we will now just put one by one all the values. So it's going to be the 1. Okay, if you put x equals to 0, we start from 0 now. So x equals to 0, 2 to the power 0, 1 over cos 0 is also 1 plus. If you put the value 2, okay, if you put the value after 0, it's going to be the pi. So whether you put plus pi minus pi, it's a mod, so it doesn't going to be affected. So it's going to be the 2 to the power minus 1, isn't it? So we will just put the value 2 to the power. Now if you put the plus pi then minus pi, so it is obviously 2 times, 1 for pi, 1 for minus pi, whether it is the value remains same, but we have to add them one by one. So it is 2 times for, it covers both plus pi and minus pi. So it is going to be the 2 to the power minus pi by pi, isn't it? Clear? And if you put the value of cos, which is a minus pi plus, whether it's a minus pi or plus pi, and mod is there, so it's going to be always 1, obviously. Now same way, it's 2 times, if you put the value 2 pi, so 2 to the power minus 2 pi by pi, and if you put this, it's going to be 1. Okay, so this goes on. Clear? So after solving this, just that what we got, 2 times 2 to the power minus pi by pi over 1 plus 2 times 2 to the power minus 2 pi by pi over 1, and this goes on. So what you see, what we observe this is 1 plus 2 times, 2 is common from everywhere, is 2 to the power minus 1 plus 2 to the power minus 2 plus 2 to the power minus 3. Is it something like GP? And if you solve this, it's from infinity, it's up to infinity. If you solve this, you will get the solution as 3. So your integral value is 3 here. Clear? This question, the electric field and magnetic field is given at a point due to two different sources, and these sources are independent to each other. And what we have to do, we have to find the relation between alpha and beta, and these alpha and beta has a relation with the E1 and your E1 and something that is B1 B2, means all are related to each other. But one condition is given, that the pointing vector is allowing this one. Now the question is about the electric field and magnetic field, and the most is focusing on the pointing vector. The one thing comes in the mind about the pointing vector is the simple thing that pointing vector is must be equals to E cross H, or you can say E cross B by mu naught. But the problem is here that it is about the E cross B, and here instead of one, means the single E and B, there are two E, two B are there, E1 E2 B1 B2. So what we will do for this, type of question. First thing is this: we have to work in a manner that E1 E2 in a same, it means the net electric field means E1 E2 should be added, the net magnetic field B1 B2 should be added. So from here what I can say that what is E net, electric field net, whether it is from the two sources doesn't matter, but we are working for the pointing vector, and that pointing vector is all over the means the net pointing vector, or the pointing vector is due to the net electric and magnetic field combinations. That's why what we will do, we will find first the E net, and that E net is obviously is going to be the E1 vector plus E2 vector. And if you do this way, so you get E times alpha I plus beta j plus E2 is E times I vector, I cap. And from there you can find the E net as the simple thing, that is going to be your E vector is equals to, if you adjust all this, it's going to be E vector, E is common, and it is alpha plus 1 I cap plus E beta j cap. Simple. Now in the same way you can find the B net also. So B net is also is going to be the B1 vector plus B2 vector as we decided for E. Now what is B1? B1 is BK cap and it's minus 2 BK cap. And if we do so, we got minus BK cap. So this is the B net. B net is along the K cap and E net is along the I and J cap. Okay, now what we will do, see, we have net electric and magnetic field. Now we can apply the pointing vector forms to and compare them to the given pointing vector that is along the I and J cap, so that we can find the relation of alpha and beta. So your S vector is going to be the E vector cross B vector over mu naught. Now what is E vector? You know very well. So I'm just solving it. Okay. So this is I, J, K cap. Clear? And what's the E vector? E vector was 1 plus alpha, or just simply write alpha plus 1 I, and your beta E is also there. So I'm writing E is there. Clear? And also here and 0. Similarly, if you see for the B vector, it's 0 here for I cap, 0 for J cap, and minus B, isn't it? Minus B for K cap. This is what we got. Clear? Now you can just solve this. We can just solve this. So if we solve, you can easily see that E, this is beta. Don't get confused, this is beta. So you can take common the B value, E value over mu naught. Clear? Which is remain with I, J, K. This is simple alpha 1, alpha plus 1. This is beta, this is 0, this is again 0, 0. And this is minus of 1. Clear? Now you can solve this. So if we are going to solve this, this is B, this is E over mu naught times, if you solve this, it's I'm just writing it, it's minus of minus beta times I cap, also minus of your J cap is there, J cap times minus alpha minus 1. Simple, this one. Okay, so what I do, this is just multiply with this one, and if you see J cap is going to be the minus times of alpha plus 1, so we solve this. Now we can simply solve this, so it's BE over mu naught, and it is going to be the minus beta I minus plus alpha J cap, and you can write this better form like alpha plus 1 J cap. Okay, because of the minus sign, so it's alpha plus 1 J cap. But as you know, the pointing vector is already given, means the direction of the pointing vector is given, and its direction is I cap plus J cap, isn't it? So just compare them. What we got? We got the direction as the I cap plus J cap, isn't it? Now what we will do? if you see, what is the coefficient of I cap? If you see, it's a minus BE over mu naught times beta, isn't it? In the same way, you can compare the J cap. Okay. So finally, we got the value of Pointing vector, that is in terms of BE by mu naught times minus beta I plus alpha plus 1 j cap. But according to the question, according to the problem, the pointing vector is along I cap plus j cap, isn't it? I cap plus j cap. So from this we can compare the I cap vector and j cap vector coefficients. So when I compare the I cap vector coefficient, what I got is BE over mu naught minus beta must be equals to 1, and from here if you find the value of BE by mu naught, it's going to be 1 minus 1 upon beta. Let this be the equation 1. Another thing is that you can compare the coefficient of J also. So it's BE by mu naught times 1 plus alpha, or alpha plus 1 must be equals to 1. So from here BE by mu naught must be equals to 1 upon alpha plus 1. So this is your equation second. So from 1 and 2, what we conclude that minus 1 upon beta must be equals to 1 upon alpha plus 1. So from here you can say alpha plus 1 must be equals to minus beta. So the relation is this: alpha plus beta plus 1 must be equals to 0. Okay, must be equals to 0. So this is your relation of alpha and beta. Canonical transformation questions are asked mostly in exam, and in this question what you observe, that something relation is given capital X and X, and the transformation is from X to capital X, and when the small p to capital P, the relation is this one. But we have studied something different in the format of the formulas. We have something different. We have relation, we have studied that the relation of capital Q small q capital P small p. Okay, so if you see this, you can see the capital P and small p is already there, but where is the capital Q and small q? These are the position coordinates. So position coordinate, instead of capital Q and small q, it is given in terms of small x and capital X. So what we can say, we just what we will do, we just replace them. So small x is small q and capital X is obviously your capital Q. And if I do so, what I got is capital Q. If you see the first equation, this one, so you can say X is replaced by the Q. So capital Q must be equals to alpha small p, and it's a small q. Again, if you see this relation, it's a capital P must be equals to beta times q square. Clear? Now the given is that the transformation between the conjugative pair of coordinate and its momentum is to be canonical. So if it is canonical, so what is the condition for canonical? It's capital Q, capital P must be equals to 1, and if you do so, it's going to be the dq over small d capital Q upon d small q into d capital P upon d small p minus d capital Q upon small dp into d capital P upon d small q, and that must be equals to 1. So you can find the values of this, all the things. Clear? So you have capital Q in terms of P and Q, you have capital P in terms of Q, isn't it? Now just place the value here, dq over dp, dq into dp over dp minus dq over dp into dp over dq must be equals to 1, and if you differentiate and put them, you will find the relation between alpha and beta. So what is dq upon small dq? So if you do this, it's going to be the alpha p, isn't it, into d capital P upon small p. Is there any relation? D capital P and small dp, so no relations, 0, minus D capital Q upon P, yes, this is going to be the alpha upon Q, and D capital P upon DQ, so it's going to be the 2 beta Q, which is equals to 1. Clear? So Q get cancelled out and this term is 0. So what we remain with, alpha beta must be equals to minus 1 by 2, or you can say alpha beta is what? This. Okay, this is plus 1 and this is 2 times. Clear? Either this and this both are correct. This is the question from the thermodynamics, because we have to find the probability, and probability of we have to find for the first excited state. Probability for the system we have to find for first excited state, and if you see here, the two electrons are there and that is in the thermal equilibrium, and that is given this one, and can occupy two sides. The energy of two different sides is given. So this is the energy. Now if J is greater than 0, then it is a constant. One thing is J must be greater than 0, and another thing, what is S? S is the spin of the electron. So it is very much clear, S is what is spin. Now U is if they are in the same side, means two electrons are there, isn't it? So what is the probability for two electrons? If two labels are there, one is there, one is here, another probability both are in the lower, another probability both are in the higher. So if electrons are in the same side, if both are in the same side, then energy is given. Clear? If both are in the same side, then energy is given. We have to find the probability. Clear? So what we will do with this now, first we will write the energy that is given. So energy that is given is in terms of J1 and J2 is S1 and S2. This is J times S1 vector dot S2 vector. But what is S vector? S vector is equals to S1 vector plus S2 vector, and if you want to find the magnitude of this, is going to be the S square is S1 square plus S2 square, and this is plus 2 S1 and S2, S1 vector, S2 vector. Clear? So if you want to find S1 vector dot S2 vector, this is going to be S square minus S1 square minus S2 square over 2. Clear? So this is what we got, the S1 S2 vector. So S1 vector dot S2 vector is going to be the S square vector, S1 square vector minus S2 square over 2. Now what is the value of S1 S2? Isn't it? You know very well, just we are putting it, S is going to be the S times S plus 1, okay, minus, what is the value of S1 square? It is S into S plus 1. So if it is 1, then always put suffix as 1. So like this. It says S2 times S2 plus 1. Clear? Now you know for S1 and S2, this is talking about the one electron. So it's, if we're talking about the one electron, S1 is going to be the 1 by 2. Same S2. So if you put S1 1 by 2 and S2 1 by 2, so it's 1 by 2 times 1 by 2 plus 1 by 2. So it's 3 by 4. Same 3 by 4. 3 by 4, 3 by 4 is minus 3 by 2. So it's S plus 1 minus 3 by 2 over 2. Clear? Now why don't we put the value of S? Because we have value of S is either 0 or 1, because of the two electrons are there. So this is S1 vector dot S2 vector. Now it is multiply with the J, so what we will do, we will multiply with the J. Clear? So if I do so, if I multiply with the J, then what we can say, this is our energy. So energy is what? Energy is J times S1, S into S1 minus 3 by 2 by 2. Clear? So we got the value of E as S plus S into S plus 1 minus 3 by 2 over 2 times J. Clear? Now you can put the value of S equals to 0 and S equals to 1, because the two electrons are there, can occupy two sides, that's why. So when S equals to 0, okay, when S equals to 0, your E will be minus 3 by 4 times of J, and this is what we call singlet particle. Why singlet? Because you know it's going to be the 2s plus 1. So 2s plus 1 value is going to be 1. That's why. Now we come to again s equals to 1. For s equals to 1, your e will be 1 plus 1, 2. 2 minus 3 by 2. So it becomes 1 by 4 times j. And if you put the value 2s plus 1 here, 2s plus 1, you got 3. So this is your triplet particle. Triplet. Clear? So your value of g is 1 and 3. So it is something like g equals to 1 and g equals to 3, and g equals to 1 has this position 1 and this has position 1, 1 1 in each side, with the j equals to 4 energy this one, and j equals to sorry, not j equals to, it's energy equals to j by 4, isn't it? E equals to j by 4 with this one, and E equals to minus 3 by 4 j with this one. Clear? Now it is given in the question, whenever the particle occupies two side on the same, two electron on the same side, either this or in this. Okay, so it is something like this, or another case is like this one. Either of these two case, your energy will remain 10G. Clear? Your energy will 10G. Now what is the probability? Probability will be summation of G of I e to the power minus beta ei over partition function z. Clear? We have to find the probability in the first excited state. So your first excited state means we are talking about, this is a ground state, G equals to 1, and first excited state is G equals to 3. So first excited state means G equals to 3. So G is value is 3 into e to the power minus, what is the value of E in the G3? G equals to 3. So it is at G equals to 3. It's going to be your triplet, and that is j by 4. So it's beta times j by 4. Clear? Over partition function. Partition function is sum of all the energies. So it's G1. G1 is 1 into energy e to the power minus beta. What is the energy here? It's minus 3 j by 4 plus second excited state is 3 into e to the power minus beta times j by 4 plus, as I told you, the same site has 10 joule it is given, so it has two possibilities, same site, either in ground state or in the excited state. So that's why I'm multiplying with the 2 here, 2 e to the power minus beta, it is 10J. Clear? So this is what we got the solution. You can easily find the solution, or you can just solve it. It's minus j beta by 4 over e to the power minus become plus 3j beta by 4. This is plus 3 times e to the power minus j beta by 4 plus 2 e to the power minus 10 beta j. Clear? This is the probability.